Today we're going to talk about higher degree polynomials and just their mins and maxes. They're also called the extreme values, those tops and bottoms of a roller coaster. To start with, I need you to get your graphing calculator out, and I want you to put this equation into y1. After you put that equation in, I want you to hit zoom 6 so you're back to the standard window as normal. So get that graphed and let's look and see what it looks like. If I have a third degree polynomial, that means that my ends are going to be going in opposite directions, odd, opposite. And we have mins and maxes in this roller coaster. Let's start with where those mins and maxes might be located. Just looking at the graph, it looks like there's something real close on the y-axis to 3, something around there, close. Also, between where x is 2 and 3, down somewhere around here is where we see a min. We also have some x-intercepts. These are all what a good graph shows. You have an x-intercept somewhere between 0 and -1. We would want to graph that. Somewhere right around close to +1 and out maybe almost to +4. So to put that all together when I graph it, because I'm supposed to both graph it and find the mins and maxes, putting it all together, it's coming up from -infinity up to that maximum, down through another 0, down to the minimum, through another 0, and up to +infinity. So that's what a good graph shows, all of those parts. But those mins and maxes, that point up here on the y-axis or close to it, and that point down here, that minimum, you need to calculate. So go back to your calculator, do a second trace, and find the min and find the max. Round to tenths, as the directions say, and you'll see that the maximum, this maximum right here, calculates right at 0.3. And you'll see that that minimum down at the bottom of the roller coaster down here calculates rounded to 2.7, -6.5. And that's all you have to do to find those mins and maxes. I need a good graph that shows the x-intercepts, the mins and maxes, and end behavior, and then find those maximums and minimums, the tops and bottoms of the roller coaster.